Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? I hope you will be fine in this moment. I mean like in this period of like pandemic, but actually we are not pandemic. And today we will learn about sequence and series. Okay, we already learned about sequence and series, about introduction to the number sequence, arithmetic sequence and series, and geometric sequence. So today is the last capture about the geometric series, everyone. So let's jump to the geometric series. Okay, in this slide right now we have adding one more geometric series and then the infinite sum of a geometric sequence. So before we jump to the infinite sum of geometric sequence, now let's jump to the geometric series. So what is geometric series? Often we have a sequence of the number and then we wish to know their sum, and geometric series is the sum of a geometric sequence. Like I said before, you can still say sum of a geometric sequence. It doesn't matter. If you want to just say geometric series, it doesn't matter too. Okay, so from here we have the sum of the first n term about geometric series. Then of course we have the apply problem. So now let's jump to the sum of the first n terms. Sum of the first n term, let us consider the geometric sequence with the first few terms. Okay, we have this first, second, 4, 8, and then 16. If you're curious how to find the sum of the first n term, we can say manually to find the first term, the sum of the first term is obviously 1, right? And then the sum of the second term is 3. Why? Because after this I will say, and then the sum of the three term is 7 and so on. Okay, let us denote Sn is the sum of the first n term, or some of another book they just say S, but in here sometimes we will use Sn, sometimes we will use S. It doesn't matter. So Sn equal B1, B2, B3, B4 until the general term of the geometric sequence. And then like in the arithmetic sequence, we are adding them the same if we are using manual. If we are using formula, it's different. So from here, we can see S1 is 1, S2 is 3, S3 is 7, S4 15, S5 in 31. So given the geometric sequence with the general term Bn equal 3 times minus 2 power n, find the sum of the first three terms. So you need to write B1 equal 3 times minus 2 power 1. It's equal minus 6. How about the second term? The second term is 3 times minus 2 power 2 equal with 12. How about the three terms equal with 3 times minus 2 power 3 equal minus 24. So from here, they ask about find the sum of the first three terms. So S3 equal the first term, second term, third term. So minus 6 plus 12 minus 24. So this one is equal with this one minus 12. So minus 18. So how about S100? So now let's jump to the example of that. So we have the theorem. The theorem of the first n term of an geometric sequence Bn is Sn equal with B1 times 1 minus k power n over 1 minus k, where k is not equal with 1. Okay, we want to prove. Because we have in the first term, in the previous Sn equal B1 until the general term Bn, we want to multiply the both sides with the key, and then the result will be k Sn, then all of the term times by k too. So from here, when we what we say, we know that k B1 it's equal with the B2, right? Why, miss? It's from the general term of geometric sequence, which is general term of the geometric sequence is Bn equal B1 times k power n minus 1. So key B1 is equal with B2 and then etc. Okay, so from here, if we subtract 1 and 2 equation of this equation from this equation, I mean like the first and then the 2, then we get Sn minus Kn, and then the rest of them follow. And then we get the we put the Sn in the front of the this one, and then we get the factorized Sn times n minus K equal B1 minus K Bn. We know that B1 cannot subtract with the right side, so it's equal, it's still B1, and then B2 can subtract with the B2. So all of them, it's the subtract is done, but they just have the left B1 and then the key Bn, everyone. So from here, it's a true Sn equal with B1 over key Bn over 1 minus K. Okay, so if we, now, this one, we know that Bn equal B1 times K power n minus 1. We want to get the formula. Okay, so this is the proof. Okay, the proof of the previous. So now, let's jump to the example. Given a geometric sequence Bn with the first term 1 over 20x and then the key equal to a ratio, find the Sx. Okay, we know that from the theorem, if Sn equal the first term times 1 minus k power n over 1 minus k, right? So from here, because they are asking about the x, so we need to change the n to be x. Sx first equal with B1 times 1 minus k power 8 over 1 minus k. Okay, so from here, we just need to substitute what we have. B1 is 1 over 120x. It's equal with 1 minus 2 power 8 over 1 minus 2. So from here, we need to find what is 120x. 2. Okay, 4, 16, 64, so 2 power 7. So this one is 1 over 2 power 7 times, this one is 1, 2 power x is 4 times 4, 16, 6, 3, 9, 6, 1, 6, 9 over 6, 5, 2, 5, 6. 1 minus 2, 5, 6 over minus 1. So from here, 1 over 100 to 20x is equal with 1, 255 over 1 minus 1. We can cancel. So the result is 255 over 120x, everyone. Given a geometric sequence with Bn with the S5 is 1210 and the key ratio is equal 3, you need to find the first term. Okay, we know that the Sn equal with the first term times 1 minus key power n over 1 minus key, right? So from here, we need, we have S5, so we just to change first key power 5 over 1 minus key. So from here, we have 1210, it's equal with 1 minus 3 power 5 over 1 minus 3. So from here, 1210 equal with the first term times minus 2. 3 power 5, it's equal with 2 for 3. So 1 minus 243. So this one, let me write again. Equal with minus 242 over minus 2. So 1210 equal B1 times 121. So 1210 over 121 is equal B1, we can cancel, so this one is 10. So the first term is 10, everyone. Sum of the first 5 elements of a geometric sequence is 93. So we can write S5 is equal 93 and the ratio is 2. So the key is equal to multiplication of third and then sixth element. So B3 times B6. Okay, so from here we know that S5 equal with the first term times 1 minus key power 5 over 1 minus key. S5 is 93. B1 is the purpose that we want to know to find B3 and B6. 1 minus 2 power 5 over 1 minus 2. So from here we continue to get 93 equal B1 times minus 1, 2, 4, 8, 16, 32. So this one is minus 31. So we got, this one is positive because we cancel. So 93 over 31 is equal B. So the B is at 3. Okay, we get the B is 3. So we can continue to find this one. B3 is equal B times key square times B key power 5, everyone. So we have the B is 3 times key 2 power 2 and then 3 times 2 power 5. Okay, we using the exponential 3 power 2 plus 2 power 7. This is enough. If you want continue, it's okay. The third and seventh term of a geometric sequence are 16 and 256 respectively. So we know that B3 is 16 and then B7 is 256. Okay, everyone. So from here we know that B3 is equal with B key square and then B7 is equal with, yes, correct, equal with B key power 6. Okay, sum of the first 7 terms. They want us to find S7. So from here we can see from B7, B key 6 is equal with 256. Okay, let me separate key power 6 to be key power 2, key power 4 equal to 56, everyone. B key power 2 is equal with this one and then they have the value 16. So 16 times key power 4 is equal to 156. Key power 4 is equal to 156 over 16. So this key power 4 is equal 16. Okay, key 4 is equal to power 4. So we can cancel. So we get the key is 2. So we need to find S7. But before that, we need to find B. Okay, from here, B3 is equal 16. And then B, we don't know what's the value, but the key 2 power 2. So 16 power 4 is equal B. So the B is equal 4. Right? So we continue to S7. S7 is B first times 1 minus key power n over 1 minus key. B1 is 4. 1 minus 2 power 7 over 1 over minus 2. So from here, 4 times minus 1, 2 power 7 is 128 less 1 minus 127. So we can cancel 1 and 1 and then times by 4. 127 times by 4. 500x. Okay, so everyone, I hope you understand what I'm explaining. Given a geometric sequence Bn with S7 equal 14 and then S14 equal 18, you need to find B15 until B21. Okay, before we continue, let me clearly about in here. if I wrote S2, so that's the meaning B1 plus B2, right? So how about if I wrote B2 plus B3 plus B4? Okay, so that's the meaning. You know that the value, if the total of them is S4, right? Yeah, S4 because S4 is equal B1 plus B2 plus B3 plus B4. Okay, but they are not start with the 1. So you need to minus with the S1 because we know S1 is B1, right? So you can minus and then this one is cancelled. So it's true S4 minus the previous number of the what's the B, everyone. So now we continue what they ask. They ask about B15 plus dot 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 until B21, right? So now we know that from this value, and then so this one S21 minus, because like I said before, in here 2, so this is 1. Because in here 15, so this is we minus with, yes, correct, 14, everyone. So from here, we can continue with what they gave in the question. They gave us S14 and then S7. Okay, we need to find S21 first. We know that S21 is equal with B1 times 1 minus key power 21 over 1 minus key, right? Okay, so from here, you need to make factorize them with 1 minus key power 7 close bracket with 1 plus key 7 plus key power 14 over 1 minus key. Okay, and then how about S14? S14 S14 equal with B1 times 1 minus key power 14 over 1 minus key. B1 times 1 minus key power 7, 1 plus key power 7 over 1 minus key. And then we have S7 again. S7 is equal with B1 times 1 minus key power 7 over 1 minus key. Okay, so we have this one. This is the equation 3. This is equation 2. This is equation 1. So we want to divide it, equation 1 and then equation 3. Okay. Equation 1 is S21 divided by S7. So S21 is B1 times 1 minus key power 7 times 1 plus key power 7 and then plus key power 14 over 1 minus key. And then we have divide with the S7 B1 times 1 minus key power 7 over 1 minus key. So from here, we can see they can be divided each other. We can cancel B1, 1 minus K7, 1 minus K7, 1 minus key, and then 1 minus key. So this one is equal with 1 plus key 7 plus key power 14, everyone. So now, let us divide it by the 2 and then the 3, which is S17 divided by S7. S17 is B1 times, okay, let me change the color to make it easier to be read. Okay, why I can change? Okay, now B1 times 1 minus key power 7, 1 plus key power 7 over 1 minus key over B1 for the S7, 1 minus key power 7 over 1 minus key. So from here, we can cancel again. Cancel, cancel, cancel. So this is the left is 1 plus key 7. Okay, so from here we get this one and continue to make the key. So S14 over S7 is equal with 1 plus key 7, right? So this one is the same. Key 7 equal with 1 minus S17 over S7, right? S17 over, yes. So we have S17 is how much their value? S17. S17, 18. S7 is 14. Okay, 18 and 14. So key 7 is equal with 1 minus 18 over 14, I mean. So key 7 equal with 14 minus 4 over 14. So this one is the same, minus 2 over 7. So from here, we can subtract. This one is 5. And then this one is 4. This one is 4. We can subtract them 5 by 4. Okay, so this one S21 over S7 minus S14 over S7. Yes, correct. S21 minus S21 over S7 is the value is 1 plus key 7 plus key 14. So, right? 1 plus key 7 plus key 17 minus S17 over S7 is 1 plus key 7. So, we can cancel this one. So, the result is key 17. Okay, now we continue to the question is S21 minus S14 over S7 is equal with key 14, right? So from here, we can continue to be S21 minus S14 is equal with key power 14 times S7. Key 14 is key 7 square times S7. Key 17 is the power minus 2 over 7. Minus 2 over 7 square times S7. S7, the value of S7, wait, let me, the follower of S7 is 14. Okay, so 14 times by 14, it's equal with 4 over 49 times 14. Okay, so this one is 64 over, oh sorry, not 64, but 28, 56 over 49. So it's equal with 8 over 7, everyone. In each year, population a certain type of insect 3 times the previous year. So that's the meaning the ratio is 3. If the current population is 5,000, so the B1 is 5,000. Find the total population of the end of the year, the 10 years. So they ask about S10s, everyone. So from here, we can continue Sn equal B1 times 1 minus key power n over 1 minus key. So from here, because they are asking Sn, so S10 equal B1 times 1 minus 3 power n, no power n, sorry, power 10, power 10 over 1 minus 3. S10 equal B1 is 5,000 times 1 minus 3 is minus 2. 1 minus 3 power 10 is 59049, or we can write to be 5,000 minus 59049. 048 divided by minus 2, right? So from here, 5,000 times minus minus positive, this one is equal with 29524, comma 5 times 5,000 is equal with 147, 622, 500. So this is the total of the population, everyone. Okay, now we continue to the apply problems. Okay, now example of the apply problem. A ball is a drop from height of 81 centimeter. Each time it bounces, it returns to 2/3 of its previous height. What is the total distance the ball has traveled in the air when it hits the ground for the 5th times? Okay, so from here we have the first term is equal 81 centimeter, and then its return to 2/3 is that the meaning the ratio is 2/3, and then they ask about S5. Okay, remember the ball, let's say this ball drove to the, let's say, the floor, and with the height is 81 centimeter, right? And then they return. When they return to the new height, they will be the same to touch the ground. So this is the same. So 81. So times 2/3. So this one is called B1 because they are bounced, everyone. When they are bounced, when from the ground to the high and then go to the ground again, they have the same. And then this is same with the B2. Okay, they will be same until B5. Okay. So from here, we know that they taught us total distance. Okay, the total distance is they are have starting point because the ball is dropped from the height, which is that's the first. So this one is the 81 is the first ball touch land plus. Okay, now we think about they have a rise and falls, so we can times by 2 times with the first time ball touch this one is 81 times 2/3. This one is the B1. This one is rise and falls, and then times with the 1 minus 2/3 power 4 over 1 minus 2/3. If you're confused about this one, remember this one is, yes, correct. This one the S5, everyone. But remember, for B1, they have a rise and falls, right? So from here, we can continue to 81 plus 2 times. It's 1 times 162/3 times 1 minus 16/81 over 1 minus 2/3. So we can continue to be 81 plus 334/3 times with 1 minus is 81 minus 16 5716. 65 over 81 over 1 over 3. Okay, so from here we can continue to be 81 plus 108 times 65 over 81 times by 3. Okay, this one is equal 27. And then take the result to be 81 plus, wait a minute, 260, and then the result will be 341, everyone. Okay, now we are done with the apply problem. So now let's jump to the exercise. Okay, there is 6 exercises that you need to work on your book. Like I said in the previous meeting, you need to work on your book even it's not collected, guys. Okay, for now, let's jump to the infinite sum of a geometric sequence. So what infinite? Like in the introduction to the number sequence, we already learned the type of the sequence. It's infinite. Infinite, they have divided by 2. Infinite sum formula, and then apply problems too. Okay, what is infinite sum formula? Okay, the theorem, the infinity sum of a geometric sequence Bn with common ratio absolute key less than 1 is denoted by S, and is given the formula S equal the first term over 1 minus key, everyone. So from here we want to prove, so we know that Sn is from the sum of the first n term of geometric sequence, and then with times, and then we change, we make the subtraction each other, and then we put the, consider the expression key power n over 1 minus key, and then when n goes to infinity for minus key more than minus 1 less than 1, the value key n over 1 minus key goes to 0, right? So from here, therefore we get S equal B1 over 1 minus key for absolute key less than 1. Find the infinite sum of the 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus ... at our infinite number. So from here, we know that the B1 is 1 and B2 is 1 over 3 and then B3 equal 1 over 9, right? So from here, we need to find the ratio. The ratio is B2 over B1 equal with B3 over B2. B2 is 1 over 3 over 1 equal B3 is 1 over 9 over 1 over 3. So this one is 1 over 3. This one is 1 over 3. So the ratio is 1 over 3, everyone. So we know that the infinity sum is equal B over 1 minus key. And then from here, we can substitute what we have. So S is B1 is 1 over 1 minus, the key is 1 minus over 3 is equal with 1 over 2 over 3. 1 minus 2 over 3. So the result is 3 over 2. So the total for the infinite sum is 3 over 2, everyone. Find the infinite sum of 200 plus 20 plus 2 plus 1 over half plus ... infinite. So we know from here the first term is 200, and then the second term is 20, and then the third term is 2, right? So we need to find the ratio. The ratio is B3 over B2 equal B2 over B1. B3 is 2 over 20, and then B2 is 20 over 200. We cancel each other. 1 over 10 equal change 1 over 10. So the ratio is 1 over 10. So from here we can continue to S equal B over 1 minus key. the B is 200. 1 minus 1 over 10 it's equal with 200 over 9 over 10. So we can write again to be 200 times 10 over 9. So this one is 2000 over 9. Okay, that's enough. Find the infinite sum of 6 minus 18 plus 54 minus 162 plus dot dot dot. Okay, from here we get the the B, 6, B1, B2 minus 16, B3 is 54. Okay, now we will find the key first. The key or the ratio is B3 over B2 equal B2 over B1. B3 is 54, B2 is minus 18 equal with B2 is minus 18 over 6. 54 over minus 18 is minus 3 equal minus 3. Okay, the ratio is correct. Minus 3 is the same. But remember, the key, absolute key, just less than 1. So the meaning key just more than minus 1, but the less than 1. So this is not include. So we can say this is no infinite sum, everyone. Okay, now we're done with the example of infinite sum formula. Now we jump to the applied problems. Okay, so let's jump to the applied problems. A ping pong ball is dropped from height of 2 meters. Each time it bounces, it returns to 3 over 4 of its previous height. The total distance the ball has traveled in the air until stop is how many meters? So from here we have the start fall is 2 meters. And then the ratio is 3 over 4. They're asking us in the total distance. Okay, so from here we can say when the ball is dropped from the height, they're 2 meters, right? But this is the starting point or starting fall. So they doesn't have bounce first. So they will have the bounce when the B1. Because when they have the bounce, they will go back with the same height, which is this one using the ratio 2 times 3 over 4. So this one is called the B1. How about B2? So you can finish this one and then you can continue to be the ball go and bounce against. And the total distance is the first fall plus 2 times, because they have bounce in the B1 times B1 over 1 minus key, or this I can say FF plus 2S, everyone, if you want to make it easier for the formula. The first fall is 2 meters plus 2 times B1. B1 is 2 times 3 over 4, right? Over 1 minus 3 over 4. Okay, so from here, 2 plus 2 times 2 is 4. 4, we can cancel 4. And then plus 3 over 1 over 4. So this is to be 2 times 3, 4 is equal 14 meters, everyone. The ball will be stopped. Now, so go to the exercise. So check yourself 13, number 1, and exercise 3, number 25, 26, and 27, everyone. So I think that's enough for our sequence and series capture. So everyone, thank you for today. Please learn more about sequence and series, because next meeting we will be have unit test, everyone. So thank you. Assalamualaikum warahmatullahi wabarakatuh.